Good day, everyone. Today, we will talk about wave and motion. But before we start our discussion, I will play a video for the introduction about the wave and motion.
Fill half of a trough with water and place some crumbled paper balls in it. Then make ripples on the surface of water using fingers. The disturbance travels on the surface of water in concentric circles of ever increasing radius till they strike the boundary of the trough. Now the paper balls move up and down as the wave passes, but the balls do not travel along with the wave. Here, the water particles move up and down about their mean position without displacement in the direction of propagation of wave. When still water is disturbed, the particles of water begin to vibrate about their mean position at the point of disturbance. These particles collide with the neighboring particles and impart some of their energy to their neighboring particles. As a result of this, the neighboring particles start vibrating about their mean position. Now these particles transfer their energy to the next particle, which in turn begins to vibrate. This process continues and the energy is transferred from one particle to other particle of the medium. Such motion is wave motion. Wave motion is the propagation of disturbances produced on one part of a medium by the vibration of its particles to all its other parts. Waves transfer energy from one position to another position of the medium and not the matter.
So that's the video all about. I hope you have gained some knowledge and understanding about the wave and motion. But that's just about an overview about the wave and motion topic. So wave motion is a propagation of disturbance. That is deviation from a state of rest or equilibrium. Wave motion is a form of disturbance produced in the medium by the repeated periodic motion of the particles of the medium. So there are two types of waves. We have transverse waves and longitudinal waves. So transverse waves is the displacement of the medium in perpendicular to the direction of propagation of the wave. While longitudinal waves are waves in which vibration of the medium is parallel to the direction the wave travels. Here is a representation about longitudinal and transverse waves. As you can notice, the example for longitudinal waves is the music system, and it produces sound waves. So the source of the sound waves is the music systems, which it travels through the direction through the ear, which we can hear the music. While the transverse waves is its television, the visible light. The source of the wave in the direction of the eye. So we can see the visible light emitted by the television. So we have the wavelength. The wavelength is a measure of distance between two identical crests, the high points, or between two identical troughs, low points, in a wave. Wavelengths represent a repeating pattern of traveling energy such as light or sound. Later on, I will show a little representation about these parts of a wave. So, time period. A time period is a time needed for one complete cycle of vibration to pass in a given point. So the frequency. As the frequency of a wave increases, the time period of the wave decreases. The unit for time period is hertz or frequency. is the number of occurrences of a repeating event per unit of time. The number of waves that passes a fixed point in a given amount of time. Unit for time is the SI unit for the wave frequency is the hertz. So as you can notice in this small representation about the parts of the wave. So the wavelength first is a distance between the throat or the crest, as you can observe here. The time needed is in the between the time needed is in the grid line where the movement of the wave travels, and the amplitude. So when the throat or the crest gets higher, or the wavelength is getting shorter, and the time needed is shorter as well. The amplitude is the maximum displacement or distance moved by a point on a vibrating body or wave measured from its equilibrium position. So the amplitude is the height of the point. It is the height of the crest or the throat. So when the amplitude is higher, the distance between two wavelengths is getting shorter, and the time period needed is getting shorter. Going back to this model, the amplitude between the longitudinal waves and transverse wave is similar. It is the height of the throat or the crest, while it varies through the wavelength. Because there are expansion and compression in the longitudinal waves, while in the transverse waves we have this wavelength that varies when the amplitude decreases or increases. For us to furthermore understand about the wave and motion, we will watch again another video. This video will help us to understand furthermore about wave motion and other derivation which is included in this topic. So here is the video.
Ever seen a Mexican wave at a sporting event? The effect is a pretty cool display that goes all around the stadium, but no one has had to move seats. All waves can transfer energy from one place to another without transferring any matter. This is done by a series of disturbances or vibrations that carry the energy. Just like the people in their seats, only moving up and down when it's their turn. Waves can transfer energy through solids, liquids, gases, and empty spaces, otherwise known as vacuums. There are two types of waves, which we look at in more detail in another video, but the basic features are the same. These four words describe different properties of waves. Let's discover what each one means. The frequency of a wave is the number of complete waves passing a fixed point in a given amount of time. This time period is usually 1 second. This is what one complete wave looks like. So if this was our time period, the frequency would be 5. Frequency is given the symbol F and is measured in units called hertz. Hertz measure how many complete cycles per second. So how many people in our Mexican wave stand up every second. The frequency and period are often confused. The frequency refers to how often something happens, whereas the period refers to the time it takes to happen. The period of a wave is the time for one complete cycle, so the time taken for one person to stand up, wave, and sit down. This would be measured in seconds. When something happens repeatedly, we say that the event is periodic and refer to the time for the event to repeat itself. The period of the Earth to orbit the Sun is 365 days. The period of a day is 24 hours. The period of a typical class at school is 45 minutes. Now for wavelength. The wavelength is the distance between a point on one wave and the same point on the next wave. For example, two peaks or two troughs. Wavelength is given the symbol lambda from the Greek letter and is usually measured in meters. Wavelengths can vary hugely in size. X-rays are very short, visible light is here, and FM radio waves are much longer. So we've looked at the frequency, period, and wavelength so far. Let's finish with amplitude. As waves travel, they create disturbance. The amplitude of a wave is the distance from the maximum disturbance to the undisturbed position. Think of a very flat sea, and then an incoming wave. The amplitude is the height of the top of the wave from the flat sea. Can you add the labels to these waves and work out the frequency? Notice that the top one is distance and the bottom one is time. Pause the video, work it out, and click play when you're ready. Did you get them right? In another video, we'll be looking at wave speed equation and connecting wavelengths and frequencies. For now, you just need to know what these 4 key words mean.
If you liked the video, give it a thumbs up.
So that is the video all about. I hope you understand what is wave motion, 2 types of waves, and the parts of a wave. Here are the questions you are going to answer.